This problem string is called near doubles, and it's the second one in the addition near doubles strategy. And this one is about the same level of sophistication as near doubles one, except we're upping the sophistication because instead of using a reckon rec for the model, we're using number lines, which the reckon rec is a more concrete representation of the numbers. This is a more abstract version using that open number line and seeing the jumps. So it is a little bit more sophisticated. Your kids have to know the doubles or at least be able to group numbers. We could represent those doubles for them. But we're trying to nudge them up into a strategy where they can use their knowledge of doubles in order to solve more complex and sophisticated problems. We're very much living here at the beginning of additive thinking. This is a very simple additive thinking strategy and a great one that if you still have kids who are kind of at the end of counting strategies, exposure to this one and continued practice could help them to nudge them out of those counting strategies and into more sophisticated thinking. As always with problem strings, the teacher facilitates the string. We don't just hand it to students to do on their own. This is a class discussion. So we lead the students through it. We model for the students using the open number line model in this case, and we let kids explain their thinking. We're not focused on the answer. We're focused on how they got the answer and helping kids to build a new relationship between numbers and grapple with the numbers to build their brains and become mathematicians. So let's get started. Okay, this is the first problem in our problem string. So the first numbers are 7 plus 7. Now, if our students know their doubles, then they're going to find this one easy. We don't want them to shout out, have them give you a silent clue that they know the answer. They're ready to share, but we want to give everybody wait time. Now, we know that the answer here is 14. 7 plus 7 is 14. But you know what? I'm going to represent that. I'm just going to represent our thinking. I'm going to start our number line here at 0. And I'm going to do one jump of 7. And that's going to give us 7. And then I'm going to do another jump of 7. And this is kind of the tricky part, but we want to make sure that these jumps are proportional. They're both 7, so we want to make the jumps be the same, which is easier said than done. But we could represent this, right? Our first 7 gets us 7. Our second 7 gives us 14. So we can see that these are equally distanced apart. They show really nicely as those jumps on a number line. Okay, next problem. So the next one is 8 plus 7. 8 plus 7. So could we use something from the previous problem to help us? Well, if we know that 7 plus 7 is 14, to get from 7 to 8, we just have to add 1, right? They're very close to each other. So could we think of this as, if we start at 0, we do our first jump of 7. Again, see how I want to make them the same. Everything is proportional. We do our first jump to 7. But I want to jump 8 this time. I want to jump 8. So can I go another 7? That's going to get us 14, but I need one more, right? We're adding one more. So just one more little jump. That's a plus, I promise. That's going to get us 15. This is kind of like saying, and we can represent a bigger jump on top, that it's kind of like a big jump of 7 plus a jump of 8. And inside that jump of 8, we have a 7 and a 1, which makes 8. So we can use 7 plus 1 more to tell us that 8 plus 7 is 15. So we want to really talk about that, really stretch that out, have students explain their thinking, have students explain it in different ways, but we want to really reinforce that 7 plus 7 is, or 8 plus 7 is 7 plus 7 and 1 more. Okay, next one. 9 plus 9. So again, our kids, they might know their doubles. They might say that that's 18. Let's represent this on the number line. I'm going to be really good here. I'm going to see how my zeros are all lined up. Now my 9 jump should be longer than my 7 jump. Let's see if I can do it. Is that about 9? There's our 9 jump. My number's line's not big enough. And then we want both the same jump plus another 9 to give us 18. If when we get really good at doing these number lines, yeah, and if you're on a big whiteboard, you might have a better chance of it. But we want kids to see that these 7s are about here, 8's kind of in the middle, and 9 is here, right? Just to show that proportion. That visual is really good for them. Okay, we know 9 plus 9 is 18. So what's 8 plus 9? 8 plus 9. Well, to go from 9 to 8, we take away 1, right? It's 1 less. So could we think of 8 plus 9 as 9 plus 9, and then we just take 1 away? Like, could we make our number line look like this? We're going to go 9. So that's plus 9. That gets us to 9. And then we're going to add another 9. That's going to get us 18, but we don't want plus 9. We actually want 1 less. So we're going to take 1 away, and that's going to get us 17. So we're seeing these two big doubles jumps, and then 1 less in there. We back it up by 1. So that's going to get us 17. So again, really talk about these relationships and how we represent them so they can see that it's just 1 less. Our next problem string is 6 plus 6. Okay, here's my number line. See how my zeros are all lined up? 6 plus 6 we know is 12, but let's represent it. So again, it needs to be a little bit less than the 7. I'm trying. 6, and then another 6. See, my 14 is there, so my 12 should be about here. Okay, good job, Jessie. 6 plus 6 we know is 12. So can we use that relationship to figure out what 7 plus 6 is? 7 plus 6? Well, to get from 6 to 7, we add 1. So if we just do 6 plus 6 and then add 1 more, will that give us 7 plus 6? I'm going to use the communicative property here, and I'm going to turn this into 6 plus 7 because I want to start with the smaller jump. Okay, so I'm starting at 0. And this is a great opportunity to demonstrate, you could do it both ways, that it's going to end up with the same thing. Then I'm going to jump another 6, and that's going to give us 12. Here's our double, but I don't want 6. I want a jump of 7. So I need 1 more little jump. That's going to get me 13. We could even represent this as a bigger jump that goes over the 6 and the 1, right? 6 and 1 make 7, and that bigger jump that's longer than the 6 is our 7. So if 6 plus 6 is 12, 6 plus 7 is 13. So great problem string to see how the doubles plus or minus 1 can help us to figure out our near doubles. Really foundational here. This one is more about using the strategy and representing it in a more abstract way. So simple numbers, a little bit more complex of a model. Here are 2 more problem strings that up the ante a little bit. They can also be modeled with the open number line like we just did to help kids really understand the near double concept. In problem string number 2, it's pretty similar, except that now we're using our helper problem to look at our clunker problem, but the 8 to 6 is now minus 2. So it's doubles minus 2. So we're just upping the ante just a little bit. Helper problem and a little bit of a clunker problem. 7 plus 7 to help us find 7 plus 9. So here we're at, oops, that's a plus, I promise, adding 2. And then 6 plus 6, 2, 6 plus 8, again, we're adding 2. So near doubles, with the plus or minus 2 in this one, so upping the ante just a little bit. In our third problem string, the numbers are a little bit bigger, they're a little bit more far apart, and we don't have a helper problem all the time. So we have an 8 plus 8, and then we can use that 8 plus 8 to solve multiple problems rather than always going like helper problem. And then we have a 7 plus 7 here. And then we have 7 plus 5. So now we're subtracting 3. So it's just upping the ante a little bit as kids get better at the near double model, which you can do over days or weeks, however you want to do it in your class. But yeah, this is a great foundational problem string to help build near doubles in our students. So I hope you enjoy this one. Thanks.